Hello, Algebra 2 folks, and welcome to Solving Absolute Value Equations. You're going to need your notes and a pencil, and if you're listening with audio, thank you very much. I appreciate that. If you aren't listening with audio, please take your earbuds out and listen. Otherwise, you might be very confused. So we already know that absolute value represents distance from zero. Sometime in your math career, you have learned that absolute value means distance from zero. Now, distance is always positive. We can't go a negative distance. So therefore, we know that the absolute value of any number is always positive, because the absolute value of 3 is actually positive 3 because it's 3 units away. How far away is it is why it's positive. Okay, we're talking about a distance. The number negative 3, absolute value of that, is 3 because negative 3 is 3 units away from 0. It's just on the other side of 0, okay, when you're looking at a number line. All right, but the distance is still 3. So we know the absolute value is always positive. But what if I need to solve an equation that contains an absolute value and I don't know how far it is from either side of that number? What we're going to do is we are going to make a connection using graphing, because we know what graphs look like. So I need you to write this down in your notes. So we have the absolute value of x plus 2 equals 5. Okay, so what we're going to do is we're going to start out with the function absolute value of x plus 2. So let's graph absolute value of x plus 2. How do I graph absolute value of x plus 2? Remember, I look at the transformations and how it's shifting. So this would shift 2 units to the left and no units up. Okay? And then it's got a 1 out here, so its slope is 1 over 1. And now remember, with a v, we know this is a v because this is absolute value signs. And absolute value means v. So I'm going to do up 1 over 1 on both sides. Okay, up 1 over 1 on both sides. And then I would draw my lines to make the V. Okay. Now what we're going to do is we're actually going to graph the other line. The other line is basically, where is this absolute value equal to? Well, it's equal to 5. So that's where my y's are equal to 5. So I'm going to graph a line at 5. That would be a horizontal line at 5. And now remember, a few weeks ago, or maybe a month ago, we talked about where two functions would be equal to each other. So where are these two functions equal to each other? Well, they're equal here and here. What x value are they equal? Well, they're equal at -7, and they're equal at 3. The ordered pair would be -7, 5, and 3, 5, but I'm not looking at the y value where they're equal. I'm looking at the x value where they're equal. So where they're equal is -7 and 3. So the solutions would be -7 and 3. Okay? So now I want you to think about this and say, okay, is there a way we can get these solutions without a graph? Because this is what the graph would look like, where the two functions are equal to each other. That is where the solutions would be. But if I don't have a graph, maybe I can use some algebra. So now we're going to do example number 2. And the way we set up these problems is that we will set up 2 problems. One for the negative sloping side, because a V always has 2 sides. It has a negative slope and a positive slope. And one for the positive sloping side. Okay, so I'm going to take what's inside the absolute value and do the positive slope. And I'm going to take what's inside the absolute value and do the negative slope. Okay, so 2 lines, essentially, one is the positive slope, one is the negative slope, and I'm going to solve where those values are. So distribute the positive, and you're going to get the same thing. Add 3 to both sides, and I get 7. This I'm going to distribute the negative, so I got negative x plus 3 equals 4. Subtract 3, negative x equals positive 1. Divide by negative 1, and I get x equals negative 1. So the two answers that will make this equation true are 7 and negative 1. Now let's plug them back in and see. 7 plus 3, or 7 minus 3, excuse me, is 4. The absolute value of 4 is 4. It works. And if I plug negative 1 in there, negative 1 minus 3 is negative 4. And the absolute value of negative 4 is positive 4 because it's the distance from 0. So both of these solutions check. And so my answers would be 7 and negative 1. Okay, I don't use parentheses because it's not an xy. They're two x values. All right, so I'm going to use these squiggly lines to say both of those answers work. All right, so now I have another problem, example number 3, which you need to also put in your notebook. This time I have absolute value of x, 5x minus 10. The absolute value of that whole thing plus 5 equals 45. Now, the first thing we have to do, and this is what we should do every time we have a function, is we always should get whatever function we're working with and isolate it. So in this case, we're working with an absolute value, so I want to isolate the absolute value. Well, how do I do that? I subtract 5 from both sides. So I have 5x minus 10, the absolute value of that, equals 40. Now I can set up the two problems just like last time, the positive slope and the negative slope. So I take 5x plus 10 and set that equal to 40. Now if I put parentheses and a plus sign, it's going to be the same thing. So I'm not going to do that. And then I need the negative slope. So I do need to put this in parentheses because it's the negative slope of the whole thing. Don't just put the negative in front of the 5. Okay, and now I'm going to solve these two parts. So I'm going to add 10 to both sides, and 40 plus 10 is 50. And 5x equals 50, divide by 5, and x equals 10. All right? And I could distribute the negative, or I can take a shortcut and divide by a negative 1 on both sides. Then I would have 5x minus 10 equals negative 40. Add 10, that gives you negative 30. I add 10 to both sides. Divide by 5. Positive 5, and I get x equals negative 6. Now I can plug these in and see if they both work. Go back to the original, okay? 10 times 5 is 50, 50 minus 10 is 40, absolute value of 40 is 40, 40 plus 5 is 45. So it checks, good deal. Negative 6, negative 6 times 5 is negative 30, minus 10 is negative 40. The absolute value of negative 40 is positive 40. And 40 plus 5 is 45. So it checks. So the two solutions are 10 and negative 6. All right, let's do one more problem because we have what's called extraneous solutions. Okay, an extraneous solution is an extra solution. And it's an extra solution that doesn't work. Okay? So we need to make sure that we check our answers and that they work, okay? First thing we do is isolate the absolute value. Well, it is isolated, so now we can set up our two equations. One is the positive slope, and one is the negative slope. And remember, again, the whole thing has to be negative, not just the 2x. Subtract 2x from both sides over here. We get 12 equals 2x, divide by 2, and we get x equals 6. Divide by our negative 1. To get rid of that negative 1, we get 2x plus 12 equals negative 4x. Subtract 2x from both sides. We get 12 equals negative 6x. Divide by negative 6, and we get x equals negative 2. Okay, so our solutions are 6 and negative 2. Let's make sure they work. 6 times 2 plus 12 That's 24. The absolute value of 24 is 24. 4 times 6 is also 24. So 24 does equal 24. So this solution works. Let's try the other solution. 6 times negative 2 plus 12 equals 4 times negative 2. Negative 12, oops, negative 2, excuse me. That is 2 times negative 2, I'm sorry. 2 times negative 2 is 4. 4 plus 12 is 8. The absolute value of 8 is 8. 4 times negative 2 is negative 8. And negative 8 does not equal 8. Therefore, this is what we call an extraneous solution that doesn't work. So the only solution that works here is the 6. Okay? And I think up here I wrote 6 times 2, and I should have said 2 times 6. But either way, it's the same thing. It's still 12. And 12 plus 12 is 24. That's why I got confused down here. 2 times negative 2 is negative 4 plus 12 is 8. All right? So you can do this checking in your head, but make sure that you do check, because we will have extra solutions that don't work. All right? So again, we are solving absolute value equations where we are setting them up to have the positive slope. We set them into two equations, the positive slope and the negative slope, and we solve for x. And we do need to check our solutions. All right, that's all I have for you. We'll see you back and practice some more. That's all, folks.